Hello friends, सबको नमस्ते. Today in this video we will make a football classification model from scratch, and also using that model we will deploy that model using a Streamlit. So in this part, there's going to be a part one where we will make a football classification model from scratch. So for football classification, I had chosen three players: Ronaldo, Messi, and Neymar. Okay, what you will learn in this video uh, is this data augmentation. What is data augmentation? How we will implement that data augmentation, and how we can see that data augmentation in our data set. Okay, all I will explain you each and every line, so don't worry. Next, what you will learn, why I'd use a grayscale images, and training time. I will explain you that don't worry. When we will create a model, I will explain you. This is a CNN model. This is a half CNN model, so don't worry. The framework that we are using is PyTorch here. Okay, and what you will learn. This is a checkpoints. You can see our callback functionalities. One of the callback functionality checkpoint basically, which we use during a train time to store or we can say to store the best model for the classification purpose. Okay. Second functionality will be a learning rate scheduler. Learning rate, you can say, the is play a crucial role that you can say it decide at what speed the model will learn the data set. Okay, learn a new pattern, or we can say learn the new pattern from the data set. This all thing is known as learning rate scheduler. I will explain you this both line, so don't worry. When I will explain you the code, I will explain you each and every line, so don't worry. This one more thing, that during a testing time, we will use a face detection, and for the face detection, we are using a RetinaFace. I will explain you there only that why we are using a face detection and why we are not using only at a test time. Okay, so don't worry. So these are all the things which I will explain you while explaining the code, or while we are explaining the skin model. So, and then this is going to be part one. The next part two will be on the next day at 7 o'clock. I will at that part I will explain you how we can deploy the model using a Streamlit. So let's get started. So this is a dataset, football dataset, containing two folders: train and test. In train, there is a photos of Cristiano Ronaldo with the class name itself of the image name, and same for the Lionel Messi. Let me show you. See, same for the Messi, and same for the Neymar. Okay, photos, you can see in most of the photos face is seen only because I have downloaded the images and cropped them, and only store the images on in which all faces will be there. Only face area is more as compared to the background. Okay, same for the test, but in test I have downloaded irregular size images because during the test time we already using a face detection. I already told you. I will explain you why I use a face detection, but in these the images is not pre-processed, you can say. Okay, but in train, images are pre-processed, and each image is mostly having the face is clearly seen, and you can see our face area is more than the background, and each size of the image is 224 into 224. Okay, see, my laptop is not that much good for the training, so I will load that Jupyter file in a Google Colab, and we download the best model from there. Okay, so let me open my Google Colab with my Jupyter file. Okay, so this is a code which I will explain you line by line. Before that, I will explain you how you can load your data, not load, how you can connect your dataset which is present in your Google Drive to your Jupyter file, or you can say to your code. So my dataset present here in Google Drive. Okay, share link, anywhere with the link, and copy the link. Okay, just copy, paste it here, and just copy this part before slash and after d slash till here. This is going to be your id, so copy this and paste it here, this at this area. Okay, display your data set which is present in your Google Drive connected to your Jupyter file. Okay, so to use this you have to use this package and you have to load that package. Okay, so let me run it. Zoom it so that you can easily able to explain. This is going to be a package, this file id, this is your output file which will be present at this place after running this. Okay, let me run it. See, it's downloading completed. Let me refresh it. See, it's visible, there's a file. You have to unzip it using this. It's done. Let me refresh it. See, your data set with two folder, train and test. Okay, now this is a RetinaFace, which is a package which we use for the face detection. Okay, let me run, first install it. It's already done. Now these are the libraries which we use for the creating a model, or we can say for the pre-processing, all those things. You know what is OS, this torch for the framework, random for the random choice, torch and for the layers, for selecting the layers, RetinaFace for the face detection, matplotlib for the plotting the images, transform basically for the data augmentation, optimizer which we use for to update the weights in a feature map, and this app for connection, you can say. I will explain you where we use this. Okay, and this for the pre-processing. Let me know which device which we are using, GPU or CPU. Let me run it. This line basically tell you which device which we are using for purpose, or we can say during running this file which device is using, whether we are using GPU or where we are using a CPU. So this is CUDA, that means we are using a GPU here. torch.device CUDA, if torch.CUDA is available, else CPU. Okay, this will define the device variable. So before explaining this, let me take one example so that we can easily explain that. Okay, let me take one name slash b slash c slash dot jpg. Let's assume this is the file name of the image, and what is this? Okay, class name. What is the line mean? I will explain you here. Okay, print class, sorry, not class. Okay, file name is not oh sorry, here not file name, here stri. See, it's a let me, okay, see, if I am using here 1, it will split only after till here it will split. After this is going to be a one, you can say one string. If I put here 2, after it will split till 2 slash will be there. Okay, let me run it. See, it's split with 2 slash, not slash, that can say you can say a bar, you can say bracket bar, you can not bracket, what's the name of the symbol. So don't forget, till now I'm not I am forgetting, so don't worry. So this till, you can say this is blank here, so after one blank it will if I am using a 2 here, it will split that list, or we can say create a list with 2 blank here. So okay, that's why. But our name is like you can see that let me show you the file name in of the images, or we can say this like this, that name of the player slash and unique ID. Let it be 102 unique ID is there. What we want this name to generate the class name list, we want this only. So one time split will be there only, not two times. So that's why I am splitting only one time here, and zero for getting a zeroth index value, because zero index will contain the class name, or we can say a name of the player. Okay, so this is a directory. This OL list directory basically fetch the name of the folders inside this directory. This data basically contain the we can say a name of the name of the players. Now we are iterating over it. Oh, so not here, it is not fetching the folder's name, it's fetching the name of the images, all the images name here. Okay, so it's iterating over all the images present in the train directory with file name here. We are splitting the file name because file name contain the class image name. We are splitting that image name with slash, with one slash, and getting only, so getting only first index values with the name, and that first index name will be appended here. Why I am using this list and creating the list and appending the class name, because here the class name will be Cristiano Ronaldo for all the images, because Cristiano Ronaldo, all the images will having more than 800 images having a Cristiano Ronaldo. Also using this we are generating the frequency, means how many Cristiano Ronaldo is present in this. After using this data, I will tell you this data will be using for here for plotting the bar graph. Okay, this way, and I have explained you this. This is one thing. Let me first run it, then I will explain you what is used telling this. See, what's the mistake here? Data is not defined. Oh, I think so I am not run it. Let me run it. Data is created. Now it's showing the bar graph with 890 images of Messi, 900 images of Neymar, and 900 images of Cristiano Ronaldo. Okay, so this is counter which we are using here. Here counter because it count the frequency occurrence of each images. It's generating the zip file of the zip file here. How many counts and labels will be here is Cristiano Ronaldo, Neymar, and see displaying Lionel Messi, Neymar, and Cristiano Ronaldo tuple here. Okay, it's plotting the bar graph with labels and count. Color will be red, edge color will be black. See, edge color will be black. Add frequency label on the top of the each bar. See how many frequency, how to display this 890 over the top of the bar will be this way. Okay, iterating over it. Counts, text ID count plus 0.1, string count here, displaying here with center, font size 12, and font weight bold. Now removing the X numerical text means this here. Instead of numerical values, we want the class name itself. Okay, for that here we are removing the asterisk with the, and or we can say we are replacing the labels asterisk numerical values with the labels. Here see, okay. Here labels is this. Here displaying the range, how many range will be there from 0 to 3, but here is range will be 0 to 3 only. By label frequency, and next title will be this title frequency category data and plot the show. This way we are plotting the bar graph. Basically it tells us how many images are present in a data set of each class name. Now we are plotting this images, 16 images from our train directory. Let me first run it, then I will explain you each and every line. So this is going to be a train directory. Okay, this basically line fetch all the images name in the train directory. Here fig representing the entire image. X basically used for iterating over the subplots. Plot dot subplots, which we are using 4 rows, 4 column, means total 16 images. Each size of image subplots will be 20 by 16. Okay, X dot table, basically X here, X is in 2D. Okay, X is in 2D. Okay, 2D dimension you can say, but here after using this, now X is in 1D. Okay, uh, why we are using this x dot variable here? Because for the ease of iteration towards the subplots. Now we are using for loop which will iterate over till 16. Okay, this from this we are fetching the image name random choice, because we are wanted random choice on or we can say represent of all the class names. That's why we are randomly choosing the image name here. Okay, we are not iterating continuously toward on a train directory. After selecting the image name, we are using this os.path.join. We are joining the image directory this with the image name. This way we are getting the complete image path. Now we open this using the image. Okay, now for getting the class name, I already told you that the image name all itself is the class name of image, or we can say class image name representing the class, representing the image only. So this way same we split zero with the you can say fill in the blanks bracket. Okay, then not represent or not know what the name of this we can say symbol, so forget me, sorry for that. This one means one time only split will be there, zero for the fetching the index fetching the string at zeroth index. Okay, now we are represent that with the class name. I already run that system. First name is Cristiano Ronaldo. Okay, see 2 means till here 2 to 4 come means each image is of 2 to 4 into 2 to 4. And see Messi is there, Neymar and Cristiano Ronaldo, and you can see each image here. See uh, phase area is more than the background. Why I had pre-processed, or why I had cropped the images from the original images and kept only the faces here, because I don't want that my model will run unwanted things from the background, because in most of the images background part is more as compared to the face of the player. I don't want that my model will run unwanted things from the background, like color pattern, which is not required for the for recognizing the you can say recognizing the player, or you can say classify the player. Okay, so that's why I pre-process, or I can say I crop the images and cap only the face area. See, this part is for data augmentation, you can say, which is useful if your data set is small. Okay, or you can say it's useful when your data set does not contain a variety of the images, or we can say flipping type images, contrast images, means a different angle images not present of one class name. So that's why data augmentation is useful. It create the images of different angles, different contrast, different brightness, with different is okay RGB values. Okay, it means it increase your data set, and it increase the chances of reducing the overfitting. Okay, which is not going to which is not you can say we developers, or we can say when we train a model, we try that a model will not get overfitted. So to that we use most of the techniques is there for we can say to avoid the overfitting. But one of the technique is using a, let's say this, using a data augmentation. Okay, first thing, it select it fetch the images, convert it into a grayscale. Now here random size 224, scale 0.8, random crop, we can say. I already cropped the images, but here it also crop the images, because we want different varieties of one images, so that our model will learn different patterns, so we can complex pattern. Our classification per accuracy will increase. Here random flip with 50% probability, rotate up to 15 degree. Here small shift and savoring, add slight blur, we can blurring, adding the blurring to the model. These two things is important. This two thing is, you can say even if you do not want your data augmentation in your during a training time. But this two important thing is important, because first thing, it convert the image into a tensor form, and second thing, it normalize the values of the images into a into a particular into, you can say, a particular range, you can say. Okay, this is going to a mean and this is going to a standard. It normalize the pixel values to using this mean and standardization. And why we are normalizing it? Because we want to increase the computation speed. Okay, and we also want and training speed will increase. And just one thing is important that we normalize it, because after we can say one of the main reason of normalizing the pixel value, that you can say, mm, one feature in the image will not get dominated. If suppose most of the pixel values is 255, okay, so that 255 pixels values, or we can say a feature, will get dominated. But if I normalize that pixel value with other values, and ranges of the pixels will be remains fixed, so that's why one feature will not get dominated towards the other. Okay, this way balancing will be there. Let me run it. Now this is going to be a class which we use for creating our data loaders. Okay, and this is going to be important. If you do not use it, it will create or throw an error, so it's required. I have kept this class name will be data. Okay, there's going to be a you can see a constructor with the directory name, with the directory files name, and the transform means data augmentations here. If transform is none. Okay, directory files, you can see a images file name. Directory is a directory, train or test directory. Here self basically give me the length, how many images is present, and this basically iterate over the age images with the IDX. IDX, if we can say, you can say a image index value in the list, direct file name, direct files list. Okay, how we can get the image path? First, it will join the image self directory, train or test, and self directory IDX basically fetch the image name index with the index value fetching the image name. This way we open the image, convert it into a grayscale. Okay, and how we can get the class name? I will tell you. Self directly by IDX fetching the class image name, and using the split with 1 and 0 index, we will get the class name. Okay, if the class name is Cristiano Ronaldo, label will be 0. If label class name is Lionel Messi, label will be 1. Otherwise, label will be 2 for the Neymar. If transformation is there, means converting to tensor, normalization or data augmentation. If it is none, nothing will be happen. If it is not none, we have to apply this transformation towards the images, and after that return images and label both. This way our data loader will be ready. First we will directory file means basically list all the images name with the image directory. Image directory basically this only, this thing, train or test folder. Okay, and this way we have created the object passing in constructor, passing three values. See here, in constructor we have to give 3 values: directory file name, and transforms. Okay, so we are passing transform directory file name, which is which kept all the images name, the image directory, train or test directory. Okay, this way we have created it. Let me run it. Now here we are creating the data set. Okay, this way we are using 2 things: torch.utils data loaders, and random split. Let me show you why we have used a random split. Okay, first data set size train, basically train fetch give us how many images are present in here. Okay, this 80% for training and 20% for validation. Now in 0.8 into dataset size, basically it decide how many images for the train. We decide here deciding how many how many images we want for the training time. We want 80% images from the train directory for the trains dataset and 20% images for the validation dataset. Okay, in this way we are calculating 80% and here. So now why we have used random split? Because it randomly, or we can say each number of images, we can say a balancing of images will be there in a validation dataset and a train dataset. It does not split the image dataset that Cristiano Ronaldo images is more in that validation dataset, and number of images in train dataset Cristiano Ronaldo is less, or we can say Cristiano Ronaldo images is more in a validation dataset as compared to an AMR images. This is not going to be happen. It's split balancing. Obviously here balancing will be there for each number of class name in a validation dataset. Okay, train object we are passing here. Now it's splitting train size and validation side. According to that, it will split the images. Basically it split the dataset here. Now using this, we are using this making a data loaders here, train data loaders. Basically these two variables you can see which we use for the training. Okay, and this we use that to how many images there. But when you will know that is length of a train dataset. See, length of a train dataset basically give you how many images present in a train dataset and validation dataset. But when we use this train dataset length and validation dataset length, you will get how many batches is there. Okay, dataset data loader, just so you will load the data from the train dataset, batch size and shuffle will be there. Okay, the same for the validation data loader, website 32 val dataset. Okay, and the sprint dataset size. See, length of dataset 2152 images for the training and 538 images for the validation size. Validation. See, here that train is an object. We want to fetch get function, and get function we have to pass index value. So it passing 0 index value, and after passing the index value, this function till here it will return two things: image and the label. Image will be at the zeroth index. For that we want this, and for the shape, after fetching the image we want shape of that image. So this giving us the shape of the first image. The shape of the images, channel is the first, then the width, and then the height. Okay, train dataset already told you 2152. Okay, let me rerun it. What is the mistake? Oh, train dataset is not defined. What is this? Train dataset. Let me copy it. Now run it. Train dataset is not defined. See, sorry, I have not run this cell, that's why it's showing the error. After when I run this, it's not showing me. Okay, so it's good. Now using this data loaders, we plot the images. Now I will show you how where the data augmentation actually works. So let me show you one thing, that 2152 divided by 32 means 67.25 means 67 batches. Let me if suppose int value will be used here, 67 batches will be there. If suppose 67 batches will be there, 67 into 32, 2144. Okay, but we have 2152. means 8 images will not be used if int value will be there, but it will not but our batch's length will be, let me show you what is the length of our batch here. Okay, our data loader length is 68, means last batch will contain 8 images only. Okay, 8 images for the training. This way no images will be every images will be used, no image will be left vacant for do not which do not use for the training. Okay, so don't get confused. Now you will get confused that we are using data augmentation here. According to that, our data set has to be increased, but here only 68 batches will be there, which containing only a 2152 images. So why how we can see that how data augmentation is implemented on on a data set. So for that, data loader, or you can say a data augmentation, only activated when we iterate over the data loader object. Okay, so this is going to be an example for you. So here we are iterating over a train data loader. Here, see, I already explained you these two lines. Now this is a class labels ranging 2 or 6. We are just plotting the images. Okay. See here, our images in a grayscale. I already told you that data augmentation converted the images, and also in our class we converting the images in a grayscale. So why I had converted the images in a grayscale, because using the converting the images in a grayscale, our computation speed increases, or we can say our training speed increases, training time decreases. This all thing going to be happen in a grayscale images. And one more important thing, that why I had used the grayscale images, because I do not want to classify the images on the basis of the tone of the players, whether it is white or we can say a skin. I don't want to classify the images on the basis of the color skin of the player. I want to classify on the basis of its appearance, on a face structure, we can say, a texture, we can say. Okay, so that's why I'm using a grayscale, because grayscale does not we can say we can say only define the texture of the face, not visible the tone of the face. Okay, that's this is going to be our main reason for using a grayscale. Here sample I permanent means it's converting this CHW to SWC, because I am sure required this you can say this structure of the image, height, width, and channel. But using a transformer in a class, it converted the images into CHW. For before we have to convert this image, we can share image shape from this to this. So that we are using permanent here to convert its shape. Okay, now I am so because in I am so in a plot I am so default value of the C map is visit, we can say. Let me show you what's the name of this C map value. So default CMAP value of the CMAP value is Viridius. Okay. Let me show you images, how the images look in a Viridius CMAP color scale, we can say. It's taking time. So see here, images will look like here in Viridius CMAP, which is the default CMAP value. So to display the grayscale image of ours, we have to manually define CMAP value to gray here. Okay. Now to set the title, we are using set title class name labels I. Basically here label define how here see here labels, this label define how which label it is, whether it is 0 index value, it will show you how many which index value index value that particular image is particular images. So labels give me the index value. Here I basically iterating over it, so an item basically to fetch the item of it. Okay, after fetching this, basically give me the index value, whether it is 0, 1 or 2. After fetching the index value using the class name dictionary, we fetch the name of the player. Okay, let me run it. Now I have shown you that I have already told you that data augmentation does it only activated when we iterate over it. It's running, it's taking time, so don't worry. See, when I iterate over the images, it's flip the images, crop the images, or we can say rotate the images. This all thing happen when we iterate over this. No, this is a this is you can say this. These are the images where the flip is there, where the crop is there, where the contrast is high. This all thing is happen when we iterate over this. Means it increasing the number of images during iteration only, and during training time only it increase the images, not before training only. Okay, now this is a CNN model which we are using. I will explain you each and every line of it so that you will not get confused. Okay, see here, this anon module, basically we are inheriting the anon module class, because anon module contains so many functionalities like forward pass, backward pass, adjusting the, or what we can say, managing the our weights and bias, and somehow those are having a lot of functionalities which we have to use during a training time. So to use this functionalities, we are inheriting it with and model. Basically, you can see our base class here, and here for after inheriting it, we have to initialize this. For initializing it, we are using here super cnn self. Then init is a constructor. Here we have to define our number of layers which we using here. Here basic in init, you can say, or we can say a constructor. Here we are not we are just defining the conventional layers, how many conventional layer we are using, how many dense layer we are using, which layer we are using. We are not connecting them. And in a forward function, or we can say in a forward function, we actually connect them. So here we are just defining them. Okay, so let me show you. uh, this is going to be a convolution layer first, convolution layer 2D, and dot. See what and dot, I already told you that and basically used for fetching the layers, and converting to is first layer with input channel is one. Means I already told you that we are not using RGB images here, we are using a grayscale image, and grayscale images having only a one channel here. Output channel means a number of filters which we are using. Okay, so here number of filters which we are using here is 16. In first layers we are using number of filters 16, which slide over the images and fetch the feature map. Kernel size means what is will be the size of the filter. Filter size will be 3 by 3. Now we are using a match normalizing here. What we use the use of batch normalization. Batch normalization basically normalize the feature map values. Why we are normalizing the feature map values? Because basically it increase the computation speed. Okay, and one more thing, that one feature will not dominate over the other feature. All feature will act as a balance, or we can say act as one only. That's why we are using a batch normalization here. Okay, now number of filters which we are using in batch normalization, same 16, what we are using here. And here the kernel size, now we are using a max pooling layer. For the max pooling layer, I already told you that max pooling basically, suppose the size of 2 by 2 means is slide 2 by 2 2 by 2 slide will be 2 by 2 over the feature map, and in that 2 by 2 it get to four values. How in out of four values, which value will be maximum will get which will be act as a pixel value. For that means combining these four values into one values for you. And in which way we combining them? We combining them in a max pool. Means out of those four values, which value will be maximum will be chosen for the feature map. Okay, here kernel size will be 2. Stride means stride 2. Let me show you what is the meaning of slide 2 with the help of the image. Okay, See, when I use stride one, okay, so it slide only one cell, okay, say 1 pixel only. So it will slide only 1 pixel. That's why, and when there is suppose this red box, in all this red box, which will be the maximum value will be chosen for here. If I am using a max polling, there are other method also for the polling purposes. But when we are using a stride here, its stride one is there. It will slide only 1 pixel. If suppose there is stride two, it will slide two column. You can say two column will be there, or we can say 2 pixel will be slided, and after two slide we can say we can say slide over two column. We can say among these values which will be the maximum value will be chosen for this, and it's up after this it will slide two here for the from the top also it will from the top also it will slide two, or we can say skip two rows. Okay, so that's how in this you can say stride 2 will work and stride 2 1 will be. Basically using of the pooling layer is to reduce the size of the feature map. Okay, to decrease the computation. Okay, decreasing the feature map, the decreasing the shape of the feature map also increase the speed of the training time. Using of this is max pooling here. There are also the other reason of using a max pooling, but I will tell you in other videos. Okay, so don't worry. So this way my first layer will be done with split 16 filter, convolution layer, batch normalization layer, and max pooling layer. Okay, same second layer. Here in channel will be the in here one more thing I want to explain you, that in channel here basically that you can see a depth of the output of the first layer. Okay, here, and one more thing, depth of the combinational layer will always is number of filter which you are using. Here number of filter which we are using is 16, so here 16 is going to be the depth of the output of the first layer. Okay, and in channel basically uh, define how many depth, what is the depth of the output of the previous layer. Now previous layer depth is 16, so that's why here 16. Now what we are using, how many of the filters we are using in this second combination layer, 32. Same kernel size 13, batch normalization I've told you, number of filters is 32, stride is 2, kernel size is 2. Same for the third layer, 32 is the previous depth, layer output depth. Output channel means number of filters is 64, size is same. This way I had created how many layers? I have created 5 layers, I think. So 5 layers will be the convolution layer, and each layer I have increasing the filter one by one. Okay. After that I am flattening that layer. That means output of the fifth layer will get flattened. Okay, this way it got flattened. So you are going to be have a question that why I had not using a ReLU layer here, activation ReLU layer here. So I will explain you that I am using that ReLU function here, but I am not defining that layer here. I can use that when we use the forward function here, or when we connect those layers. And that time also I can define a ReLU layer. I will show you how we can do that. Okay, so don't get confused. After you are using flatten, that means we are flattening the output of the fifth layer. Now we are using normally we are using a 4 dense layers here, but last layer will be the output have 3 features. Let me explain you one more thing. Here this output of the fifth layer will be 5 by 5 into 5 by 12. So input will be this, and output will be means how many numbers of neurons of number of neurons which will be connected to the number of neurons with the previous layer of the previous layer, or we can say after we flatten that layer is 1024. Okay, here also we are using normalization here because each neuron has its own value. We have to normalize that also, so that no one neuron feature will get dominated. Okay, Here also, in feature, I will told you tapped number of neurons of the previous layer is 1024, and output feature number of neurons which we want that to connect from the previous layer is 256. Okay, same way here. So these are the three dense layer after the flattened layer. Okay, and this is going to be the output of the our CNN model. And here we are using a softmaxed layer. Okay, so output will be 138 128. I will told you it is going to be the output of the previous layer, or we can say number of neurons of the previous layers. And output feature means output means here I had used a 3 here because number of classes which we have here is 3: Messi, Ronaldo, and Neymar. So that's why output neurons of the last layer will be 3, and I am using this here softmax means basically softmax basically we can say convert the neurons value into your probability values, and when we add those last 3 neurons probability after using after a softmax function, the probabilities value when you add that will be get 1. So that's why uh, output after the softmax we can use that neurons values as a probability. That's why I'm using the softmax, or we can say score. Now here we have already defined what layer we have to use. We have not connected them. Now here in this forward function we have to connect them. Here x you can say is act as the image. Okay, here x is act as an image. So images come. Now we have to connect that image with the first convolution layer. Now after converting the first convolution layer, we have to connect it with the batch normalization. Now here, now I am not defining that ReLU layer, ReLU layer here, or we can say ReLU activation function here. Okay, because I can either I can define it here, or I can either directly use it here. It's two ways. If you define it here, you have to use it here. Okay, if you do not define it here, even after that, even after you will not define it here, you can use it here by using this f here, functionality function. Okay, after ReLU means after batch normalization we have to use ReLU here. ReLU basically gave us the maximum values. If the value goes to the negative, it will change that value to 0. If the value is greater than 0, it remain that value same. After using that we have to use pool. Basically pool is for reducing the shape of the feature map. This way you can say this way I have connected the 5 here. X is act as the image. This going to be the output. So this is going to be a simple way for connecting. This is going to be you can say this I am writing too many things, too many layers, repeating the you can say repeating the line. Yes, I am repeating the line, but this is going to be a simple. This I have created this to explain you more easily how the layers is connected one by one. I can mix I can compress this lines into one line also. If I can, this 4 line will be converted to one only, but this is going to be complex for explaining also. So I'm not using that for the explanation purpose only. I have separately connect them. Now after 5 layer, flatten will be there. Now we have to connect the fully connected layer. First we connect the fully connected layer, now fully connect the batch normalization, then ReLU layer. This way we have connected all the 3 layers. After this we have to connect the last layer, which gives us the output of the CNN model. Okay, and after this we have to connect the softmax because it convert the nearest values into a probabilities values. Now return X. Now model with the object with 2 device. We have to see this 2 device. This is going to be the important thing. Why this is going to be important things? Because we have to define this, because 2 device basically tell it suppose our image is in a GPU and our model is in a CPU. So this is going to be a problem. So this all things means model, images, everything have to be in a same device, or we can say a same hardware. For that we have to define this 2 device receive. Basically will tell that all things will be in the same device. Unexpected argument num feature, where it is, let me show, let me see. Oh, num feature 16. What's the problem here? not features. Let me run it. It's going to be simple. Now, after that, I have to see the summary of the images. How the number layers output look like. What is the shape of that? So that we have to use ch, and we have to pass one thing. Here, what is the shape of the input image? Input image shape will be in tensor format, and tensor format it will be is in a CHW format. Okay, it gives us a summary of the images. See, conversion layer 1 output will be 16, 22, 22. Conversion layer 4, 2D, 1, 2, 3. See how many layers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 24 layers is there. Okay, and each output shape is look like this. And how many parameters we have this way? This 14, 1. Okay, 14,09575 is a number of parameters. How many trainable parameters? Same, which is going to be trained on during the training time. Okay, now we have to define the optimizer. Optimizer basically update the weights. Okay, now cross entropy loss. Here we are using cross entropy loss because we are have a number of classes is more than two. We are not using a binary cross entropy loss because we have not classified that whether it is a Ronaldo or not. We are not playing here yes or no. We have to play that in the particular way what class name is there. It is whether it is Messi, Ronaldo, or Neymar. Okay, for that we have to use cross entropy loss. Adam, we have to use Adam optimizer. For a model parameter is basically parameters here that what how many it gives the number of parameter which is trainable during training time. Learning rate which I have used. I have tried so many hit and trial method. I have trained more than 5 to 6 times and decided that 0.01 is the best learning rate. Okay, for my model, and number of epochs is 100. How many time I have to train the model is 100 here. Learning rate, I have to tell you that if you learning rate will be too slow, the model will learn slowly. If learning rate is too high, it basically skip the global minima which is used, which we actually want to achieve during training time. Okay, let me run it. Now this is going to be a model training. This for list basically fetch, or we can say store the data of the loss accuracy at each epoch. Okay, train loss, train accuracy, validation loss, well accuracy. Okay, now this is going to be the callback functionalities which we use for the for during training time, which we use for storing the best models and scheduling the learning rate, or you can say during training time changing the learning rate during training, so that our model will get so that model get more accuracy, we can say. Okay, so here we have to first define best value of loss for storing the loss, because we have to its value is defining here, it is having infinite values. Okay, because according to the according to validation loss only we store the model. Suppose the validation loss is less, means we store that model whose validation loss is very less among the training epochs. Okay, this is going to be a checkbox directory where we store the model. Okay, it will make the directory checkpoint directory. Exit, okay, true means if it is exit, if it's not exit, it will make the checkpoint directory. Now here scheduler basically define change the learning rate values during the training time. Torch.opt-in learn LR scheduler cosine angle uh, angling from restart optimizer T0. Here T0 means till 10 the learning rate value will be changes after 10 epoch learning rate value is starting from the same value 0.01. You can say till 1 from 1 to 10, learning rate value will be changed at each epoch. After 10, 11th epoch, at 11th epoch, learning rate value will be the same which we have decided before. It means 0.01. From from 11th to 20, value will be changes. After 20, 21, at 21 epoch, if learning rate value will get same 0.01. This way the learning rate scheduler will get activated. So now we started a training. Okay, first epoch range will be epoch. Now models and training mode. Correct here means how many times a model is perfectly we can say correctly classify the images. Train running loss basically calculate the running loss at each batch, not at each epoch, at each batch you can say. Okay, we are appending that. Okay, so this here train data loader, we are iterating over a train data loader. Okay, first thing we have to see that image, that model and image should be on, or labels should be on a same device, so we have to use this. Let me resume it so that you will get more confused. No, so not so you will not get get clear picture of that. Okay, convert the gradient values into 0 for each wedge. See, optimizer 0 grade. Why we have to use this here means at each batch uh, optimizer's value, or we can say a gradient value, will convert into a 0. Why we are converting at each batch? Because if we do not convert the gradients values to a gradient value at each batch, means previous batch gradient value will get accumulated to the current batch gradient value, and this way our weights value will not get change, or we can say change drastically or change unnormally. Okay, that's why at each batch we are converting, or we can say we are fixing the gradient value to 0, and gradient value one of the value which we use to update the weights. Okay, now we are passing the image here, get fetching the output. Now here we are calculating the loss using this criterion output, we are an output and labels only. Loss will be calculated. Loss dot backward here the weights value is get calculated. Okay, after calculating the weights values, optimizer dot steps basically uh, update the weights. Here weights is calculated, here weights is get updated. Okay, you get the clear picture what is the step of the each and every line here. First, gradient value will be get 0 at each batch, get the output, get the loss according to the loss, uh, calculate the weights value. Now optimizer dot step basically update the batch value. Okay, this way the training is process will going on. Now after that, loss dot item will give me the loss of each batch, and we have to loss of each batch. Okay, now we have to uh, for calculating you can say for calculating loss for the entire data set of a training data set, we have to add it. Okay, that's why total training running loss basically initial value will be 0, and here we are adding the loss here. After that, torch.max will give me two things. Print basically the value here, and here this blank here will be the index value. So that's why we want value here, not the index value. Okay, how many what is the prediction of the images? Okay, this is a line, and here we are calculating that classification of the images, how many times we can say how many times a model is calculated correctly. Here we are calculating. This is not for the entire, you can say entire data set, or we can say for one epoch. This is for only a batch, and each batch it is 32 images is there. Here this prediction, if prediction is equal to labels, if and it is correct, submit and item. Here we item basically fetch the value here. Sum basically we are summing it, we are adding it. Okay, this way how many correction is there and how, what is the loss is calculated for the each batch, not for the each epoch. After fetching this, after when this for loop is over, it means our training data set images is over for one epoch. After one epoch, training time training for training data set is epoch, not for the validation, for the training data set only. Okay, we have to store it here. This train data loader. Okay, epoch train loss, train data loader give me how many batches is there, and training loss. Here we are. I have already told you that training loss basically uh, give me loss of each epoch. That's why we are dividing it with the train data load, means how many batches is there. But here CNN 100 into correct into length of the train data set. I have told you this here. For each image value is added here for the entire batch, but here for the each images. That's why we are dividing here with train data set, means total number of images for in the train data set. And here we are calculating train accuracy for each for one epoch. Now we are appending this in a list which we have created above. This way we have to we are using it. After that we are printing the message that after train data set training time, what is our accuracy and what is our loss. Now with torch no gradient, here what is the meaning of that? Means we do not want gradients, or we can say we do not want any updation on our weights. Model eval means now model is in a evaluation mode. Now we have to evaluate our model, means how our model is correctly classifying to a unseen data set. Now same way correct and validation learning loss, same way iterating, same way the same device getting the output, calculating the loss, calculating learning loss, same way getting the prediction, same way correct how many correction is there, same way calculation, same thing is there, same thing. But one different thing, wow, you can say during training time, what is the difference between a trained dataset training and validation dataset? Here there's two things. Torch no grade means we do not want any gradients, or we can say we do not want any updation on a weights. And here the model is an evaluation mode, not in a training mode. This two thing is different here. Other thing is the same calculations, same display. Now see, oh, sorry. Now see, here after here checkpoint is required. Checkpoint is there. Okay. I have already told you that checkpoint means saving the best model. We have to check the validation loss, and epoch validation loss and best validation loss. I already told you that best validation loss value before is defined before in a code is infinite. Before training is infinite. If epoch loss is less than, it will change the best validation loss value, then it will checkpoint point means where we have to store the model. Now it will save model at that place. Here it now after saving it will display the message. Okay, now learning rate, we have to see, I have kept this learning rate in this for loop, not in this, and not in this for loop, and not in this for loop. But I have kept this in this means epoch for loop. I had kept it because learning rate scheduler basically update the learning rate after each epoch. That's why I have kept it here. Okay, this way it will update the learning rate. learning rate. One more thing I want to say, told you that scheduler get last LR. Basically, it will give me the learning rate of last. Okay. I have told you that 11th epoch value will be 0.01. No. See, at epoch 1 value will be 0.0979 according to learning scheduler. At second epoch its value is 0.094. It means it's you can say it's decreasing. Okay, ultimately at 10th epoch its value is 0.01, which we had defined, which we have defined, okay, for the learning rate. This way, now 11th learning rate will be 976. Same way, same learning rate schedule will be performed, but at 20th epoch you can see learning rate will be 0.01, which we have defined. This way the learning rate schedule will perform. Let me run it. I have explained you this whole code with each and every line with easy way, so that you will not confuse. Before now this going to be run. Okay, it will take time, so let me explain this. See, after getting this epoch log, we have to plot the training accuracy and validation accuracy graph. Fig dot axis, I have told you x1 here. Okay, x1 plot point epoch log means how many epochs is there. Training loss will be there. Red color with a straight line, not dashes line, straight line. Labels train loss we want. Same way for the validation loss, label we what we want, validation loss. For the dashes layer, we are using dashes line for the red. X label will be epoch, Y label will be loss, and legends we want to show the legends here, site title loss but epoch. Same way for the accuracy. And see here train loss is a list which we have used. Okay, I have explained you. Let me run it. It will get activated when a trading will be get over, trading cell get over, lot the sale. Now this torch dot save basically save the best model whose validation loss is very less. Now here, see, now to load that model we have to use this. Give the directory name and model.device and model.eval. Okay, now here model will be the evaluation mode. One more thing I want to check, told you that when you save the model, that there the class name which you had used, where you define the layers and connected the layers, that class name is already it's also will save in that bash mod.pth file. Okay, so to when you use that, we have to give this what is the CNN here. But here I have already run that cell, so it will not show, does not show me any error. So I will explain you when I will make a part two video where I will deploy that model. So in part 2, when I will deploy model, at that time I explain you what is the use of the CNN class even after we save the model. Okay, I will tell you at that time only. So don't worry. Let me run this cell. Okay. Now why I'm using now RetinaFace or a face detection in this? Because uh, you can see in my dataset face area is more as compared to the background. Okay, so and one more thing, that I want the classification not on a entire images, where the in most of the images you can see the background is more as compared to the face area. So our model will get confused, so that so get to increase our accuracy, or you can say increase our accuracy, or our model will classify the image more accurately. I'm using a face detection here, so that it fetch, or we can say crop the image and get the face area only. And using that face area, I will fetch that face area to my model, and my model will classify that. If I will not use this face detection and does not provide my cropped faced image to our model. So model will not classify more accurately, okay, because most of the images background is more. So this is not class, or we can say not class function. We are passing the image path. It's open the images here. It After passing the image path, it will tell me how many images it's shown. Okay, if suppose in faces length is greater than 2, because it means we do not want that images, because multiple face our model will get confused, or we can say our model not trained on multiple faces. So that's why. Okay, and if suppose no face is detected, we will print this message or return none. If one face is there, it will first, here this faces dot keys, give me the list of of faces, of number of faces is there. Okay, after fetching the list of the keys, we fetch first index value. Okay, it will give me the key. After using the key, we will fetch their hair face, basically give me all the details of the face which is present on my image. Here facial area, which will give me the bounding boxes values. X1 y1 means coordinates. X1 y1, you can see our top left, and y x2 y2 we will be our bottom right. Now you can see, when we use this face detection, you can see that it's give me only a facial area, but I want to but I want whole head. So to get the whole head of the person, or we can say a player, I expand that bounding boxes values. And how I am expanding it, see, this way. Max expand y1 expansion means what is the value of x1. Let me show you one image so that you will not get confused. Okay, see here x1 basically give me this value. Suppose if I minus 60 pixel here, it will reach till here. Okay, till here it will reach. Suppose it reached till here, so x1 value will be get negative, and when we try to plot it, it will give me it will throw me the error. So to avoid the error, we are using here 0, means max 0, means so that when even after you reducing the x1 value, it will not get out of the image width, or you can say. It's a same way. One more thing I want to tell you, that for the y1 0 start from here. To expand this dimension, I have to reach till here. To reach here, I have to reduce the y1 value with 60. Same way, if I reduce the 60 value, suppose it does not so that it will y1 value will not reach till to this to this value, or we can say negative value we are using here, so that 0 value will be remain even if the value will be get negative. Same way for the x2. If suppose x2 I want to expand it, I have to add the 60 pixel here. If suppose I add the 60 pixel, the width the value of the x2 will not get beyond the width of the image. So that's why I'm using here minimum image size 1, or you can say here image size 0 will come, and here image size 1 will come. Image size 0 will give me the width, and image size 1 give me the height. And for the y2, suppose if for the y2, if I will expand it to the 60 pixel, it will move to this side, to the bottom side. I don't want that the value will not get beyond the height of the image, so that's why I'm using a minimum. If suppose the value will get beyond the or you can say above the height of the image, it will give me height value only. So this way I'm expanded it, and this way this line basically cropping it and resizing it. Okay, why here I'm resizing it? Because in all the images, or we can say in a training time, we are using 224 into 24 size of images. Same images, image size should be there, or before during test time only. Otherwise, it will throw the error. This is the you can say this is the result of the detection function which I have created. I have plotted it. I have using here two one row and two column, means two plot will be there, and here see here see first it will give me the image path. I will pre-process it. It will give me the you can say the cropped image or the expanded face. I will plot that image and plotting the original image. Okay, this way I will show you the difference between the original image and after using a function here. Now here I am using a test, or we can say a uh, evaluating the model. This is textuality test file name. Basically give me the file names of each image in a text directory. This all the pre-processing. See, uh, for the testing time we do not require any data augmentation. What we required, uh, just the tensor or a and a normalization, which we have used. But you can say uh, I'm here using a transformation variable which I had created before, or we can say above in a code. Same thing. Even if you just use here, just normalize the image or two tensor here, just two things. The even after that also your model will get does not throw any error. In short, I want to say that what all the pre-processing which you had applied on an image before training. I think our training is get over. Yes. So our last saved model will be this, and its accuracy is 90.3. Okay. See, the model which we have saved have achieved 90% accuracy. Okay, I have explained you this whole thing. See, this is the result of our model. Let me remove it. Let me run it now. See, this is original image. See, if I train the model on this type of images where the background is more as compared to the face, our model will learn lot of unnecessary things. That's why I have pre-processed all those images or cropped those images and kept only the faces area where face area is more as compared to the background image. Okay, see, this is the image after the expansion. Suppose uh, same image will not come because I have used here random choice here, so same image will not come. But I want to show you that what is the result when I will not use expansion. Okay, see, this is an image. If I will not use any expansion here, it give me this face area only, but I want a complete head. This complete head I want for my classification. Little bit background is okay, but not more background. So that's why I expanded it. Okay, I've used expansion here. Let me run it. Now test time. This is a test directory. Oh, what I am telling you, that all the pre-processing which you applied on the images has to be performed before the training. So that's why I'm using a transformation, and squeeze means it is a single image whose size, or we can say shape, is in a CHW. But during training time, what we are passing the sizes batch CHW. So to reshape it, or we can say optimize the shape of the image, we have to use here and squeeze, which add one dimension, or we can say optimize the shape of the image and convert it into this way, this format, BHCHW, where one is a wedge, or you can say one image, 360 by 60 pixel. Yeah, not 60 by 60 will be there, 224 into 224 will be there. Okay, so don't worry. And squeeze basically include one dimension, we can say add one wedge b here. Okay, in optimize the shape. Transformation, because it convert the image into tensor or normalize it with all the functionality which we have used for in the training time. Okay, images is a list, I think so. It does not use any here. See, class names, variables. This I have explained you why I am using here while loop, because see what is the function of pre-processing of, we can say, detection crop phase, giving to none, return none also if suppose multiple phases there. Okay, if I will use for loop and it will return the none here, a for loop will get stuck. So a mod so that our follow will not get stuck, or you can say that there is a way to, so that a model follow will not get stuck. But for my ease, for my comfortable, or we can say for my easiness, use value pair. If press image will be there, I will continue it. You can use it, you can use for loop also. Okay, don't worry. Image path, it give me the image path after random choice from the file name of the images. This give me the expanded face area from the images. If it pass me none, I will continue it, so that model more loop will not get stuck, and all the 16 images will be there. If I use for loop here and it for loop it will return none, it will stuck, or we can throw an error. Okay, changing to a pre-processing image in a grayscale, because we are using a grayscale images for the training. Here pre-processing images means function, this pre-function which expand the dimension, or we can say expand the shape, and pre-process the image means converting the image into tensor and normalize it values. After converting the grayscale pre-processing, just say one more thing, that model and image will be on the same device, that's why we have to use it. Now here passing the images, argument max basically give me the value, or we can say index value for the class name, for that we can get the label of the image. We are opening the image here. See, I'm not plotting the image of the, we can say, a crop image. Here I am plotting the original image. Okay, here setting the title, here h1 n plus 1, and I want to explain you is for why I have used a while loop. I have already told you, but somehow I think I have not explained you properly. So suppose I have used a for loop here. Okay, it will loop. Okay, when suppose at ith value 5, it will my detection model throw me the none here. So ith value will get increase. Okay, I don't want that. I want to okay, that's why I'm using while loop here, so that I will update uh, when our model detection function did not show any none here. Let me run it so that we can see how our model is performing at 90% accuracy. Wait, it's taking time, so wait. See, it's performing good. Ronaldo, Messi, Ronaldo, Cristiano Ronaldo. One time wrong. Messi, Ronaldo, Neymar, Ronaldo. Two times. Nee, Ronaldo, Neymar. Only one time our models get confused, or we can say predicted long. Uh, If suppose if I will not use this detection function and just pass the pre-processed image even after without the face, let me show you what will be the result if I will not use pre-processed image. Okay. How are you can say how our prediction get affected? I will show you. Okay. uh, Let me run it, but one more thing. Pre-process image size should be 224 to 24. Okay, let me run it now. See, without using the crop face images, how our model get affected? Let me show you how our model accuracy get affected. See, this is Lionel Messi. No, one time wrong. Neymar, Messi, Neymar, two times wrong, three times wrong. Okay, four times wrong. Neymar, but Ronaldo. Neymar, Neymar, it's also wrong. Five times wrong. And Neymar, but it's Ronaldo. Six times wrong. See, uh, how our model get affected if I does not use that detect and crop function. Okay, so that's why I'm using detect and crop function so that a model get fetch, or we can say upload loaded with only the image or of only a face image only. Okay, so that it classify the images more accurately. Let me show you difference after using a face detection function. See, let me check how many predictions are wrong. One, two, I think so two predictions are wrong. See, only two predictions are wrong when I had used a face detection. But previously, when I does not use a face detection function, our predictions more than six predictions are wrong. So this affect. That's why I use a face detection. Okay. So this is over. Now I will download it. This my best model. Okay. After downloaded it, I will use it for the Streamlit, or we can say I will deploy that model after using it using a Streamlit. So this is still here. It is a part one. Okay, in part two, I will use this model using a Streamlit and deploy that model. So that's going to be the end-to-end complete end-to-end project. So wait for the part two, and please like, subscribe, comment, and share. This motivate me to give you a best explanation. So please like, share, and subscribe. Thanks, and wait for the part two. Part two will be on the next day at 7 o'clock. Okay.